Okay, so we've been looking at this idea of loan repayments recently, and here's another common type of question that they like to ask. And it involves finding the amount of regular payments that are made to pay off a loan. So in this situation, we've got Alex, and they've got a loan of $400,000, borrowed at 6% per annum, compounded monthly. And that's really important, so I'm going to try to keep that at the back of my mind. If the money is paid back at regular monthly intervals over 18 years, or 216 months, they want us to find the following things about it. The first thing to note is, okay, I've got an annual interest rate per annum, but it's compounded monthly. And the other thing is, I notice that I'm making regular monthly payments. So, really important, the first question is asking me to find the monthly interest rate. That's really easy. All you need to do is take 6%, and because there are 12 months in a year, you divide that by 12. That's all you got to do. And you should get 0.5% when you put in that calculator. But as a decimal, that's expressed as, just to double check, 0.005. Okay, 0.005. Now that I have that, it's going to be really easy to express the amount owing after a certain number of months. Because I remember I'm making regular monthly payments. So I need to use this monthly interest rate to account for that. So let's, for part B, let A n be the amount owing after n months. And it's really important that when we're looking at these kind of questions, we really want to take it step by step. I don't want to jump to 216 months because not only is it very easy to get some values wrong, but they generally ask you to derive these. They generally ask you to show you for the first couple of months and then want you to show it for that last repayment that they make. So if I start by looking at the first repayment, I remember that when I'm looking at the repayment, I calculate the interest first, and then I subtract that repayment amount. So always calculate the interest and then subtract the repayment. So in this case, my loan is $400,000. And so this is where the monthly interest rate comes in. I'm going to be multiplying that by 1.005 to add on that extra interest. But that month, I'm also going to be making a monthly repayment. And I'm going to let that equal to M, because I don't know what that is yet. What about the second month? Well, I use the same idea. I can say that this whole amount here, I am accumulating interest on, because that's the amount that's owing. Right? So I'll take this whole amount, 400,000 times 1.005 minus M, and I'll multiply that all by 1.005, but then I'm also making another monthly repayment, so that's going to be subtracting M again. Let me do this one more time just to show you how this is going to simplify out. Oh, I should simplify this one out first. So this will be 400,000 times 1.005 all squared minus M times 1.005 minus M. I can start to see the pattern emerging, but I just want to do one more term so I can see really clearly what my series is going to look like. So I've got 400,000, or what I had over here, times 1.005 squared minus M times 1.005 minus M, all multiplied by 1.005, and then another monthly payment that I'm making, so I'm subtracting that M value. And if I expand this all out again, I'll get 400,000 times 1.005 cubed. I'm multiplying 1.005 to all these terms, squared, M times 1.005 minus M. So I can see the pattern that's emerging. All I'm doing is raising this monthly interest rate to the power of the installment that I've made for this part of the series over here. And then this is actually something, another series that's really happening. It's not a series though. This part of the series. So now that I've written out all these terms, it's really clear what pattern's emerging with this expression. For this part of the expression, all I'm doing is multiplying 400,000 by the monthly interest rate, and raising it to the power of the installment that I'm making. So for the first time, the first installment, raised to the power 1, second installment, raised to the power 2, third installment, raised to the power 3. Now over here, I've got something else happening. I have a common factor of m for all of these terms. So I'm going to factorize that out because it's going to look a little neater. I take a factor of m out, or negative m out, I'm going to be left with 1.005 all squared plus 1.005 plus 1. Now generally when we look at series, it's much easier to see them as an ascending series. So I'm just going to swap the order of this. I'm not going to change the value at all, I'm just going to swap the order here. Okay. Now I can really clearly see. Okay, I'm starting from 1 as my first term, and I'm multiplying by 1.005 to get to the next term each time, until I have a power which is 1 less than the installment that I'm making. So if I want to generalize this, if I want to find the expression for the amount owing after 216 months, I can easily write that as A sub 216 is 400,000 times 1.005 to the power 216, and I want to subtract m, the monthly installment, multiplied by 1 plus 1.005 plus 1.005 all squared, all the way until n minus 1, or in this case, that would be 1.005 to the power 215, so 1 less than the monthly installment that I'm making. Alright, now that I've done the hard work and written out that expression for the amount owing after 216 months, I want to answer part C now. And part C is asking me to show that the monthly repayment amount is approximately $3,032.65. How am I going to go about that? Well, I really want to use this expression that I've created here. What this allows me to do is, in the situation where I've actually repaid the whole thing after the 216 months, what would the amount owing be? Well, if I've repaid the whole thing, the amount owing would just be 0. So I would say, let A 216 equal to 0, because that's the situation where I've repaid off the whole thing. And then I want to substitute A 216 as my 0 value there. And I'm just going to keep everything else as it is. Now this is just going to be a number value here, so that's not too difficult to work with. But what I really want to do is think about how I could evaluate this, because this is a geometric series. And I realize, well, I have a partial sum formula that allows me to calculate the sum of a geometric series. And remember that S of n is equal to A outside of Rn minus 1 all over R minus 1. So in order to evaluate this series, I really need to write down my A, R, and N values. Now A is really easy. Well, my first term there, that's just a 1. What's my R value going to be? Well, I can see that each time to get to the next term, I'm multiplying by 1.005, so that's fine. What about my N? So remember, the N is the number of terms that I have. And I see that I go up to all the way to the power 215. But if I think about it, if I'm starting from the power 1, I'm going all the way to the power 215. Over here I've got 215 terms. But remember, what's your first term? The first term is 1 here. That's actually part of your series. So you have all these powers from 1 to 215, but you also have this term here, that 1 constant. So the number of terms is actually going to be 216. You've got 216 terms there. And then you can just substitute it into your partial sum formula. You've got 1 times 1.005 to the power n, which is 216, minus 1, all over 1.005 minus 1. If you evaluate that, what do you get? 1.005. You get 387.35 and a lot of decimals. So I'm just going to store that value in my calculator there. Now what I want to do is I want to take this value here. I want to take this value. And let's keep going. Because remember, what's the goal? The goal is to show that the monthly repayments is approximately $3,032.65. So I'm trying to find the value of m. All I need to do is really just rearrange my equation now. I know that this series will evaluate to about 387.35 with a lot of decimals, but I want to get m by itself. So all I'm going to do is just rearrange my equation. I'm going to add this part of the expression to both sides, so I'll get m outside of 387.35 equals to 400,000 times 1.005 to the 216, and then because these two are just multiplied together, I just want to think opposite operations, so I'll divide both sides by this number here. So m will equal to 400,000 times 1.005 to the power of 216, all divided by this number. And when you do that, that's exactly right. You get 3,032.65 to the nearest cent. So you can see, just by breaking down this question into steps, although there are a lot of calculations you need to do, you can easily find that monthly repayment which pays off your loan of $400,000 in 216 months.